Hello guys, and welcome back to another episode of chemistry. Today we'll continue our study into the alkynes. Okay, today specifically we're looking at the preparation of alkynes. Preparation of alkynes. All right, so alkynes can be prepared in a number of ways. Okay, or in a number of method, or using a number of methods. Okay, and I'm going to look at some of those methods today, all right, as it concerns the scope of this class. Okay, so likewise, in the last episode, I forgot to tell you, all right, I didn't remember to tell you that the general formula for the alkynes, is what? CnH2n minus 2. All right, so please take note of that. This is the general formula for the alkynes. Okay, general formula for the alkynes is CnH2n minus 2. Do not forget that this tutorial is brought to you by the O3 Schools JAMB CBT Practice app. It is all you need to succeed in your exam. All right, so please go to Play Store immediately, download the application, and start practicing your way to tremendous success. You can look into our testimonies, all right, from this channel and see how the app has helped a lot of students. So your case will not be different. Okay, the app has all the past questions you need, as lecture notes to study, as question start feature, as UTME mock challenge every Saturday. You compete with all your mates that are writing JAMB for a particular year. All right, you win amazing prizes, get used to JAMB past questions, build your confidence towards the main exam. You see your results released also every weekend. So it helps you to track how prepared you are for the main exam. Okay, so please download the application and get your activation paid. Okay, pay for it's just a little token. All right, pay for the activation and start practicing. Let us see preparation of alkynes. Okay, so we said that alkynes can be prepared using a number of methods. Number one is we can prepare alkynes using calcium carbide and what? And water. When you react calcium carbide and water, and alkyne, okay, will be what will be formed. All right, so let us see that reaction. Number one, okay, reaction between calcium carbide and water. Okay, calcium carbide, of course, is what? Is CaC2. CaC2, this is calcium carbide, while this is what now? Water, H2O, the water that you know. All right, so when we react with calcium carbide with water, all right, and an alkyne, all right, is what? Is formed. An alkyne is formed. Let us see that reaction. So this is calcium carbide, CaC2, all right, then plus what now? H2O. All right, so when we do this, okay, let me just write the balance equation once and for all. CaC2 plus 2H2O, this will give us what? Ethyne. All right, ethyne, C triple bond to what? To C. All right, so this is what? Ethyne. Okay, H, or you can put the H here and H here, but of course, you know, there can only be 4 bonds around what? The carbon atom. So I'm going to have what? 1, 2, 3, 4. All right, why for this one? 1, 2, 3, 4. Okay, so now what's the other product that is formed? The other product is what? CaOH2. Okay, so this is what the first method of preparing what? And what? An alkyne, like ethyne. Okay, this is calcium carbide. Okay, this is what? Water. All right, then this is what now? Ethyne. Okay, ethyne, or the one we call what? Acetylene. Okay, then this is what? Calcium hydroxide. Okay, so this is what the product of the reaction. So the first method, like we said, is the reaction between calcium carbide and water. So please commit it to memory. If for any reason you have not liked this video, what you are doing is very wrong, please click on that like button immediately, because it will make other students like you easily find these tutorials and also learn. Do not forget to also share this video to your class group, to your friends, to your Facebook, to your loved ones. Let them all come and learn and keep succeeding in their exam. So let us see another method that we can use to prepare alkynes. Okay, and this second method we use haloalkanes. All right, we use dihaloalkanes. All right, we do not just use haloalkanes, we use dihaloalkanes to prepare alkynes. All right, so number 2 we say using haloalkanes. All right. So this is what an elimination reaction. Okay. What happens here is what is elimination what reaction. Okay. So when we are using what dihaloalkanes to prepare what alkynes, okay, it's a what is an elimination what reaction. So the first halogen that is attaching itself to the what to the haloalkane, okay, will be what will be eliminated. Then also on further reaction, we now what eliminate the second what halogen that is attaching to itself. Then we now have what our alkyne. All right. So this is what I mean. Okay, if you have what a dihaloalkane like this CH2Br. Okay, CH2Br. Okay, so in a way you understand, maybe you want to write it this way, CC. Okay, call here Br, here Br. Okay, it's the same thing as this, just to complete your structure. All right, complete your structure. You know, this is what? This is an alkane. All right, so 1, 2, 3, 4. Single bond, 1, 2, 3, 4. So it's complete. So this structure is also the same thing as what? As this. All right, so we condensed it here, but here what? We drew what? The structure. All right, so that we can use what? This dihaloalkane to what? To prepare what? To prepare an alkyne. How do we do that? All right, we react the dihaloalkane with what? With KOH, alcoholic KOH. All right, and then we now have what? Our products. Okay, let us see what we have. So if you have C, bonded to what? To C, then here Br, here Br, then of course you now have this. All right, you now have this H. What's the name of this compound to start with? Okay, the name of this compound definitely will be what? 1, 2 di what? Dibromoethane. Be very simple. So this should not be something that should be play for us, okay? Because we have seen the nomenclature of what? Of alkanes and alkenes, so it becomes very easy for us to name any compound. So we react this with what? With KOH, alcoholic KOH. All right, so alcoholic. Okay, and of course the product of the reaction that we have, of course, firstly, okay, the first thing we have what? We have what? An alkene. Okay, so what we have C bonded to what? To C. All right, one of the bromine, okay, will be what? To be eliminated. All right, so we eliminate this one, leaving just this. So I'm going to have what? Br. Okay, Br. Let me write it properly. Br. All right, then of course we can complete our structure. This is 1, 2, this is 3, this is 4. H. This is 1, 2, this is 3, this is what? 4. Okay, so this is what? One of our products. Then you see, when we eliminated what? One alkene, or sorry, one what? Halogen, rather, we have what? We have what? An alkene. All right, so we don't have alkyne yet. So we have to what? Further react it again with the same what? KOH and what? With the same alcoholic KOH before we now have our what? Our ethyne. All right, so now the other product of this reaction, of course, you see there's KOH here. Okay, that means this K must have taken one of the halogen. All right, so one of the product also of this reaction is what? Is KBr. All right, then plus what? H2O. Okay, so these are the product of what? Of this reaction. But of course, we do not. This is not what we want to prepare. All right, we do not want to prepare what? An haloalkene. All right, what we want to prepare actually is what? Is an alkyne. So this reaction is not done yet. Okay, so we have to further eliminate this bromine from this reaction. So this will now react also with what? KOH, alcoholic KOH, to now give us what now? The alkyne that we're looking for. So let us see that. All right, so we're going to have what now? As this. Let me take this space. I'm going to have C, double bonded to C. Okay, Br. All right, then this H. All right, so it's complete like this. Okay, so 1, 2, 3, 4, complete. 1, 2, 3, 4, complete. So we react it with what again? With what? With KOH, alcoholic. All right, alcoholic. All right, so what will this one now give us now? We're now going to have what? Our ethyne. Okay, so we now have our ethyne. So this is what will be our product. C triple bonded to what? To C. Okay, this is our H. This is our what now? H. Okay, we have eliminated the second what? Halogen. Then of course plus what? Plus KBr plus KBr, then plus what? Plus H2O. All right, so this is what, how we can what? Use dihaloalkanes to what? To produce what? An alkyne. Okay, the first step reaction is to react with what? KOH, alcoholic KOH, to give us what? A what? An halo what? Alkene. All right, then of course, that is an alkene that has an halogen, haloalkene. Okay, then on further reaction, now gives us what now? Now give us what do we call it now? Now give us what? Ethyne. So this is our what? This is our ethyne. Okay, sorry, ethyne. Okay, this is what? Potassium bromide. That is what? Water. Okay, so this is what? The simple what? Step reaction that we can what? Use to what? To prepare what? An alkyne. All right, from what now? From dihalo what? Alkenes. Now, please, you have to know that for this reaction, okay, once we react what this alkene, this what halo what alkene, okay, with what? With KOH and alcoholic, or with alcoholic or KOH, to give us this ethyne. The ethyne that we usually get is not usually in vast amounts. Okay, it's not usually what? It's not usually that much. Okay, we do not get what? Enough what? Ethyne from what? From this reaction. Okay, so if we want to now get what? Enough ethyne for this reaction, the reagent that we use is not alcoholic KOH. Okay, what we now use is what? Is sodium what? Amide. Okay, sodium amide. Some we call it was sodamide. Some people call it sodamide. It's also called sodamide. It's called what? Sodium amide in the presence of what? Liquid what? Ammonia. Okay, so this is now the reagent that we use to what? To react with this what? Haloalkene. Okay, so that the ethyne that is gotten, okay, will be what? In enough what? Quantity. So if we want to have enough quantity of what? Of ethyne, we do not what? Use what? Alcoholic KOH to react or what? To further react on what? On the halo what? Alkene. Okay, instead we use what? Sodium amide or sodamide with what now? Liquid what? Ammonium as what? As a solvent. Okay, so please, you must take note of that. It's very, very important you take note of that. So this is the second reaction, the second what? Preparation method, or method for preparing what? An alkyne. Now let us see the third method. All right, we can also use what? Tetrahalides. Okay, on this second one, we use what? Dihaloalkanes. Okay, so we can also use what? Tetrahalides. Using tetrahalides. So this will be number three. Using what? Tetrahalides. Okay, and tetrahalide is what? Something like this. C. All right, yeah, Br, yeah, Br, yeah, Br, yeah, Br. We can complete the structure H, what? H. So this is what? A tetrahalide. Okay, it's an what? It's an alkane that has what? 4 halogens combined to what? Or attached to it. So it's a tetrahalide. So we can what? Also what? Through elimination, produce what? An alkyne. Okay, from what? From a tetrahalide. All right, so let us see what the reaction what? Pathway. Okay, so let me draw this again for the sake of space. All right, so what we do is that we react this tetrahalide with what? With zinc. Okay, we react the tetrahalide what? With zinc. So we're going to have what? C, Br, then I'm going to have H. All right, H. So what we do is that what? We react with what? Sorry, not H. This is a tetrahalide. This is Br. This is also what? Br. All right, so we react with what? We start with zinc, Zn. Okay, of course, this will now have what? Of course, like I told you, it's also what? An elimination reaction. Okay, so if we react with what? With zinc here, then what we're going to have, of course, but the halogens that are eliminated are the halogens on what? On the alternate sides. Okay, so like you eliminate this and this. You don't eliminate halogens on the same carbon. So you eliminate one halogen from here. You eliminate one halogen from what? From the other what? Carbon. All right, you get me? So you do not just eliminate what? 2 halogens once from one carbon. Eliminate what? 1 here. Eliminate what? 1 here. So this is what I'm going to have. I'm going to have C. Then bonded to what? To C. All right, so here we're going to have Br, then here we're going to have what? Br, then plus what? Zn, Br what? 2. Okay, so 2 halogens have been what? Eliminated from this what? Reaction. Okay, because 2 halogens have been eliminated, you can call this reaction also what? A dehalogenation reaction, the halogenation reaction. Okay, because we have removed two halogens, okay, from what? From the reaction. All right, so now, if we want to now control this reaction, what we use again to further react is to now get our ethyne. Remember, this is not our final product. What we're looking for is ethyne. It's an alkyne, not what? An alkene. Okay, so to control this reaction, we use what? CH3OH. Okay, and what? And zinc. Okay, so remember, what is this called? CH3OH is either called what? Methyl alcohol. Okay, we can also call it wood spirit. Wood spirit. We can also call this also methanol. Okay, the simplest what? Alkanol we have. All right, so please take note of that. So to control this reaction, so that we now have our final product, our final destination, what we do is that we further react it with methyl alcohol, okay, and zinc. Okay, so let us see that reaction. Let us see the end of the reaction. Okay, so here we're going to have what now? C double to C. Here Br. Here Br. Okay, is this complete? Okay, this is H. This is what? H. Okay, sorry. Okay, yes, this is H. 1, 2, 3, 4. 1, 2, 3, 4 is complete. All right, then plus what now? Zinc again, but this time is controlled in the presence of what? Methyl alcohol. Okay, then what will now give us is what now? We now have our ethyne. Okay, ethyne, H. Okay, then plus what now? ZnBr2. All right, so this is what? Another word, dehalogenation reaction. Okay, so this is how we can prepare what? An alkyne, all right, using what? Tetrahalide. Okay, using tetrahalide. It's as simple as ABC. So understand the first reaction, all right, and how we eliminated what? Two halogens on adjacent side. Okay, not on the same carbon. Okay, then of course we now had this first reaction, this alkene. Then of course, then we now further reacted with this alkene with zinc, controlling with methyl alcohol or wood spirit or methanol as we have it, to give us an alkyne, which is what? An ethyne, and zinc bromide. All right, so this is what the third method we can use to prepare what? An alkyne. All right, let us see another method. Going to the fourth method to prepare what? An alkyne. This one we call it what? Haloform. So we can use the word an haloform to what? To prepare an alkyne using haloform. Haloforms. Number 4, using what? Haloforms. All right. So haloforms. Okay, the haloform of chlorine is called chloroform. Please take note of that. The haloform of chlorine, just like halogen forms, okay, or halogen formats. All right, so the haloform of chlorine is called chloroform. The haloform of bromine is called bromoform. The haloform of iodine is called iodoform. Okay, so from chloroform, all right, we can be able to prepare an alkyne. All right, so we can use chloroform. Chloroform is CHCl3. Okay, that is what? C. Okay, Cl. Then H. This is what? Chloroform. Okay, so we can prepare an alkyne using this chloroform. Let us see the reaction pathway. All right. So we're having chloroform. H. I'm going to have C. H. All right. Then this is what? H. All right. Then plus 6Ag. All right. Silver. Reacted with silver. 6Ag. Then of course plus Cl. Okay, then this will now give us what now? The product. Okay, so what is happening here? Sorry, not H, not H. Remember, it's chloroform we are using. This is what? Cl. Okay, so this is what is happening. These Cls, okay, will now react to talk with this Ag. So here in the product side, we're going to have what? 6AgCl. All right, so I'm going to have 6AgCl, then plus what? Plus our ethyne, okay, plus our alkyne. So this is what's left, CH. All right, this is what will be left. Okay, so this is not complete. This is what CH here. All right, so what will be left is what? This Ag will react with this chlorine, okay, with all this chlorine here, then of course, what is left is what is CH and what and CH, which is what our ethyne. Okay, so I'm going to have 6AgCl, then plus what now? C, the triple bonded to what? To C. All right, this is our H, this is what? Our H. It's as simple as ABC. So using alloform is very easy, okay? We just react what? Chloroform plus 6Ag plus another chloroform, okay? So that what? The Ag, the silver, will react, okay? We react with what? With the chlorine atoms, and then of course we're going to now have what? Our ethyne left. It's as simple as ABC. So that is the fourth method. Let us see the fifth method for preparing alkynes, and this one is called Cope's electrolytic method, or Cope's electrolysis. All right, Cope's electrolysis. That is number 5. All right, Cope's electrolysis. So in this method, we use what? A carboxylic acid. All right, we use a carboxylic acid and react it with water. All right, and then we pass what? Current through it. That is electrolysis. We pass current through it, then it gives us what? Our alkyne. And some other products that are very, very also what? Important. Okay, so this Cope's electrolysis or Cope's electrolytic method can be used to what? To prepare other reagents. It's not just what alkynes. Okay, so you can get carbon dioxide from it. You can get hydrogen gas. Okay, so let us see the reaction quickly. So number 5, Cope's electrolysis. Okay, so the reaction, I'm going to have C bonded to C, yeah, COOK, then here COOK. All right, so this is what I'm going to have to begin the reaction. Then remember, here's a double bond. All right, COOK. You can complete what your bonds 1, 2, 3. Of course, here there will be H. 1, 2, 3. Here will be what? H again. All right, then of course we're okay. So now we have 4 bonds there. Now, so this is what we're going to what? To react. We're going to react this with what? With water in this Cope's electrolysis. So we react with what? With water plus H2O. Then of course, remember we are passing currents. So electrolysis. Okay, we pass current through it, and then the product of reaction is what? Our ethyne. We have what? Our ethyne to what? To what? To C. Yeah, H. Yeah, H. Other products are what? 2CO2 for a balanced reaction. The balanced reaction, other products are 2CO2 also, then plus what? 2KOH, then plus H2. This is our balanced what? Reaction. Okay, so in Cope's electrolysis, we react with a carboxylic acid with water and then pass current through it. Then we'll have our ethyne or our alkyne. Then we have what? Carbon dioxide. We have potassium hydroxide. Then have what? Water. So 4 products. We are getting 4 products in Cope's electrolysis when preparing what? Alkyne. Okay, it's not just the alkyne. Okay, that we get. We get what? Carbon dioxide. We get potassium hydroxide. We also get what? Hydrogen gas. So please take note of that. So let us see. The last method, let us look at the last method so I do not bore you too much. We can prepare what? Higher alkynes, okay, from a lower alkyne, like what? Acetylene or what? Ethyne. Okay, so from ethyne, we can what? We can prepare what? Higher alkynes like propyne, like what? Like butane, like what? Like pentyl and so on. All right, so now how do we do this? Let us see how we do this. So we can say what? Using what? Acetylene. Or using what? Using lower alkynes. All right. So using lower alkynes, like for example, acetylene. Okay. So that's what now? C2H2. That's C2H2 from the general formula CnH2n. Okay, minus 2. Abi, for 2 carbon atoms, what? C2H2 times what? 2 minus what? 2. That is C2H4 minus 2, which is what? C2H2. So this is how you use what? The general formula. For say for a situation where you are not sure. Okay, if you are not sure, please don't write your general formula out. That's why you need to know your general formulas. All right. So now using what? Lower alkynes like acetylene, we can what? We can make what? Or prepare higher what? Alkynes like CH3 C triple to what? To C, which is what? Propine. All right. We can make what? CH3, CH2, C triple to what? To C, like butane. All right. And so on and so forth. So let us see, how do we do this? How do we get this? Okay, so what we do is that what we react what? Acetylene, which is C2H2, right? With what? With sodium, with sodamide, okay? Or we call it what? Sodium what? Amine, okay? Or sodium amide, all right? We react it with sodamide, okay? In the presence of liquid what? Ammonia. Now, but when we do that reaction, right, what we get is not just what? An alkyne directly. What we get is what? Is an alkyne that has sodium attached to it. So we now have to what? Remove what? That sodium from it by reacting it with what? With either what? Methyl bromide, okay, or what? Ethyl or bromide to get what? Propine, or to get what? Butane, respectively. Okay, so let us see the reaction. So we react it with sodium what? Amide. Okay, let us see. We are going to have C triple what? To C. This is what our ethyl now. Ethyl. All right. So then plus what now? NaNH2. All right. So react this what our ethyl with NaNH2. Then we're going to have what? In the presence of what now? Liquid ammonia. All right. So our sodium will attach itself to what? To this what? This negative side, okay, of this what? Of this ethyl. This, no, this is negative, this is positive, okay? Then this is positive also, this is negative. Okay, so what will happen is that what? This our sodium will attach itself to this, then this our hydrogen atom will attach itself to what? To this NH2. All right. So when we do that, we're not going to have our product. We're going to have C to C. All right. Then I'm going to have C triple to C. This is negative. Then our Na, okay? Then plus what now? Plus ammonia. All right, so this will be our product. C triple to C plus then what? Our ammonia. Then plus what now? Then plus what? Plus ammonia. Okay, C triple to C, our sodium. Then plus what? Ammonia. This compound here is called sodium acetylide. This one is called sodium acetylide. This is our ammonia. Okay, this is our sodamide. Okay, sodamide. Okay, or sodium what? Amine, or sodium what? Amide. Okay, so now that is the first what? Step. But what you are actually looking for is not just what? It's not this. It's not what you're looking. It's not sodium acetylide you are looking for. What you are looking for is what? Is an alkyne. So to get our alkyne, we further react it to what? With what to call it? React it to what? With methyl bromide. Okay, to get our alkyne, we further react with what? CH3Br. Okay, so to get our propine now, when we react to what? CH3Br, we're going to get our propine. Okay, so now let us see. Let us see what I'm going to have. So I'm going to have this. That's C triple to C. Okay. Na, this is positive, this is negative, okay? So C triple to C Na, then plus what now? CH3Br, okay? So which is what? Our methyl bromide. Okay, so once we do this reaction, we're going to have what now? Our product, okay? Our product will be what? C triple to what? To C. Okay, sorry, not C triple to C, because this is a methyl group already here now. So I'm going to have CH3, then C triple to C. Okay, then plus what again now? Our sodium what? Bromide, NaBr. So now that is what our this now become our what? Our propine. Okay, it has what? 3 carbon atoms. So that's what our propine. So also if we want to get what? Our butane. Okay, what we just do, instead of using what? CH3Br to react this, we use what? CH3CH2Br. Okay, so once we do this reaction, that is C triple to C Na, then plus CH3CH2Br, are going to have what now? CH3CH2 C triple to C. Okay, then plus what? NaBr. This is what our what now? Our butane. All right. So that is what the easy ways we can prepare what? Alkynes. They are very, very easy. Just for you to practice. Then takes one or two practice, and then you get them off your chest and you put them in your head. All right. So thank you so much for joining. Okay. In the next episode, we're going to talk about the reactions that alkynes undergo. All right. And after then, we'll talk about the test for triple bond, and we'll talk about the uses, and we are done with alkynes. Thank you for joining in. My name is Master T, the Grand Commander of this great army. All right. I would like you to keep marching and keep succeeding. Thank you for watching.